In this video, I'm going to explain how to reduce a rational expression. The basic idea is, if you see a factor in both the numerator and denominator, you can cancel them out. So look at the first example. Do you see x plus 1 cubed? Well, that's 3 factors of x plus 1. And in the denominator, there is 1 factor of x plus 1. So you can cancel 1 factor out from both numerator and the denominator. So if you cancel 1 factor from 3 factors, 2 factors are left. In the same way, if you see x plus 2 squared and x plus 2 cubed, you can cancel 2 factors out and remove 2 factors from 3 factors. 1 factor is left. So this rational expression is reduced to 4 times x plus 1 squared. This thing is gone. This is gone. So in the denominator, we have x plus 1 to the first. That's only 1 factor of x plus 2. Okay, so that's the answer. Let's work out the second example. Before you try to reduce any given rational expression, remember this: you have to factor the polynomials. So factor this. 9 is 3 squared, so this is the difference of squares. X squared minus 3 squared. So it is factored into x plus 3 times x minus 3. In the denominator, we have a trinomial. So we're going to try to look for two numbers that add up to 2 and multiply to negative 15. Those two numbers are 5 and negative 3. 5 times negative 3 is negative 15. At the same time, 5 plus negative 3 is positive 2. So the denominator is factored into x plus 5 times x minus 3. Now you see x minus 3 both in the numerator and denominator. You can cancel them out. And this is reduced to x plus 3 over x plus 5. Okay, next example. Reduce x plus 2 over 5x. Well, it is tempting to cancel x out because that expression is both in the numerator and the denominator. And you might say this is 1 plus 2 over 5. But this is totally wrong. Why is it wrong? This is wrong because x, this expression x in the numerator, this is not a factor. This is a term. You can cancel only factors. You cannot cancel terms. What is a factor? A factor is something multiplied by other expression. This is a factor. This is 5 times x. This is a factor. But this is a term. It is not a factor because this is x plus 2. It's not x times 2. Okay? So let's start over. So, can you factor the numerator? Well, this is already factored. This is only one factor, x plus 2. You cannot break it into the product of two things. There's no way to do that. So this is together. This is one factor. This is irreducible. So in fact, there you see 3 factors: x plus 2, 5, x. Nothing is the same as any other thing. So this is already reduced. There is no way to reduce this any further. Okay, the next example. This one is a little tricky, in fact. It is very tempting. Again, it's very tempting to say, well, can we just cancel these two out, x plus 1 and x plus 1? They look exactly the same. But no, you cannot do that. Why? Because x plus 1 here in the denominator, this is not a factor. The denominator is not factored yet. This is not factored. Why? Because it is some expression minus another expression. It is not some expression times another expression. This is not minus. It's not multiplication. The numerator, on the other hand, is factor. This is x plus 1 times x minus 1. So this is factor, but denominator is not factored. So how do we factor the denominator? Let's start it over. How do we factor the denominator? Let's look at the denominator. We can actually simplify. I'm going to multiply this out in 3x plus 3 minus 6 and reduce it to 3x minus 3. And then 3 is a common factor, so this is 3 times x minus 1. So that is the factored form of the denominator. So this is the numerator, x plus 1 times x minus 1 over the denominator, 3 times x minus 1. Once you do that, you can see this factor is cancelled with this factor. So the answer is x plus 1 over 3.